Have you ever wondered if two particles separated by the entire width of the universe could somehow know what the other is doing instantly? What if I told you that Einstein himself called this phenomenon spooky action at a distance because it terrified him so much that he spent decades trying to prove it was impossible? Welcome to the mind-bending world of quantum entanglement, where particles become mysteriously connected in ways that seem to violate everything we thought we knew about reality. I'm talking about connections so strange that when you measure one particle here on Earth, its partner particle orbiting a distant star will instantly respond, faster than light could ever travel between them. Now, before we dive into this rabbit hole of quantum weirdness, I need to warn you about something. What I'm about to show you isn't just another science explanation. This is the kind of information that once changed how I see absolutely everything around me. After understanding quantum entanglement, you'll never look at a pair of dice, a coin flip, or even your morning coffee the same way again. But here's what makes this even more incredible. The phenomenon we're about to explore isn't just some abstract physics concept gathering dust in university textbooks. Quantum entanglement is the foundation of technologies that are reshaping our world right now. We're talking about quantum computers that could solve problems in seconds, that would take our best supercomputers millions of years. We're talking about communication systems so secure that any attempt to eavesdrop would immediately destroy the message. We're talking about a revolution that's happening whether we understand it or not. And the most beautiful part? You don't need a physics degree to grasp the core concepts that are driving this revolution. In fact, some of the most brilliant minds in history struggled with these ideas precisely because they tried to force quantum mechanics into the box of classical thinking. So, over the next few minutes, I'm going to take you on a journey that starts with a simple question about spinning coins and ends with you understanding one of the most counterintuitive phenomena in all of science. We'll explore why Einstein lost sleep over these ideas, how scientists proved him wrong in the most elegant experiments ever designed, and why quantum entanglement might be the key to understanding consciousness itself. But first, let me tell you a story that will change everything you think you know about the nature of reality. Imagine you have a magical pair of coins. These aren't ordinary coins, though. When you flip the first coin and it lands heads, the second coin, no matter where it is in the universe, will instantly land tails every single time, without fail. Even if the second coin is on Mars, or in another galaxy, or floating in the depths of space billions of light years away. Now, your first instinct might be to think, well, that's easy to explain. The coins were programmed beforehand. One was always going to be heads, the other tails. This is exactly what Einstein thought, and it seems like common sense, right? But here's where things get absolutely mind-bending. When scientists actually tested this idea with real quantum particles, they discovered something that shattered our understanding of reality. These particles aren't pre-programmed. They don't have predetermined values. Instead, the act of measuring one particle literally creates the result for both particles at the exact same instant, regardless of the distance between them. Think about that for a moment. We're not talking about one particle sending a signal to the other. We're talking about instantaneous correlation across any distance. This isn't science fiction. This is science fact, demonstrated in laboratories around the world every single day. But wait, it gets even stranger. Scientists discovered that if you try to measure both particles in different ways, you can actually prove that no hidden information was traveling between them. The connection is deeper than any signal, faster than any communication, and more fundamental than anything we experience in our everyday world. This is quantum entanglement, and it's so weird that even the scientists who discovered it didn't want to believe it at first. Let me paint you another picture that might help this sink in. Imagine you have two magic dice that are entangled. You put one die in a box in New York and ship the other to Tokyo. When someone in New York rolls their die and gets a 6, the person in Tokyo will simultaneously find that their die shows a 1. Not a second later, not after any signal could travel between the cities, but at the exact same moment. Now here's the kicker. Before anyone rolls the dice, neither die has a predetermined number. The numbers don't exist until someone actually looks. But the moment someone in New York observes their die, both dice instantly decide what numbers to show, and those numbers are always perfectly correlated. This isn't just theoretical anymore. Scientists have created entangled particles and separated them by hundreds of miles, even sending them to satellites in space. And every time they test it, the results confirm this spooky connection. But quantum entanglement gets even more fascinating when you realize that it's not limited to just two particles. Scientists have entangled groups of particles, creating what they call quantum networks. Imagine not just two magic coins, but entire bags of coins all connected to each other across vast distances. Change one, and you instantly affect them all. This is where the real power of quantum entanglement starts to reveal itself. These quantum networks are the foundation of quantum computing, where entangled particles work together to perform calculations that would be impossible with traditional computers. We're talking about machines that could break every encryption system currently protecting your bank account, your private messages, and government secrets. But don't panic just yet. The same quantum properties that make current encryption vulnerable also provide the solution. Quantum entanglement enables a new kind of communication that's absolutely unbreakable. If anyone tries to intercept a quantum encrypted message, the very act of observing it destroys the entanglement and alerts both the sender and receiver that someone was listening in. Now, you might be wondering, how do we actually create these entangled particles? The process is surprisingly elegant. Scientists use special crystals that can split a single photon of light into two entangled photons. These twin photons share a quantum connection that persists even when they're separated by enormous distances. It's like taking a single note of music and splitting it into two notes that forever remain in perfect harmony, no matter how far apart you move them. Touch one note and the other resonates instantly. But here's what really blew my mind when I first learned about this. The connection between entangled particles isn't just strong, it's perfect. In our everyday world, no connection is perfect. Radio signals get weak over distance, phone calls drop. Even the strongest materials eventually break under stress. But quantum entanglement never weakens, never fails, never degrades with distance or time. This perfection has led some scientists to propose that quantum entanglement might be fundamental to how the universe itself works. Maybe space and time aren't the basic building blocks of reality. Maybe entanglement is deeper than both of them. Think about it this way. If two particles can be instantly connected across any distance, what does distance even mean? If the connection happens faster than light could travel, what does time even mean? These aren't just philosophical questions anymore. They're driving real research into the nature of reality itself. Some scientists are exploring whether quantum entanglement might explain how consciousness works. After all, your brain contains billions of neurons that somehow work together to create your unified experience of being you. Maybe quantum entanglement is what allows these separate neurons to function as a single coherent mind. Others are investigating whether entanglement might be the secret to teleportation, not teleporting objects like in Star Trek, but teleporting information. Scientists have already successfully teleported quantum states from one particle to another, perfectly recreating complex quantum information at a distant location while destroying the original. And here's something that might keep you up at night. If particles can be entangled across vast distances, and if everything in the universe is made of particles, then maybe everything is connected to everything else in ways we're only beginning to understand. Maybe the universe isn't a collection of separate objects floating in empty space, but a single, unified system where every part is intimately connected to every other part. This idea has profound implications. It suggests that the boundaries we perceive between objects, between ourselves and the world around us, might be illusions created by our limited perspective. At the quantum level, separation might not exist at all. But let's bring this back down to earth for a moment, because quantum entanglement isn't just changing how we think about reality, it's changing how we live in reality. The first quantum computers are already being built by companies like IBM, Google, and dozens of startups around the world. These machines use entangled particles to solve certain types of problems exponentially faster than traditional computers. We're talking about drug discovery that could find cures for diseases in months instead of decades. We're talking about weather prediction that could save thousands of lives by accurately forecasting natural disasters. We're talking about artificial intelligence that could solve climate change, optimize global logistics, and maybe even help us understand consciousness itself. The quantum internet is also becoming reality. Scientists have already created quantum networks connecting cities across the globe. In the future, these networks will enable perfectly secure communication, distributed quantum computing, and maybe even quantum-enhanced sensing that could detect gravitational waves, dark matter, or other phenomena that are currently invisible to us. But perhaps the most exciting application is quantum sensing. Entangled particles are incredibly sensitive to their environment. By carefully measuring how entanglement changes, scientists can detect magnetic fields, gravitational changes, and temperature variations with unprecedented precision. This could revolutionize everything from medical imaging to archaeology. Imagine quantum sensors that could detect cancer cells long before they form tumors, or quantum magnetometers that could map the human brain's activity in real time, or quantum gravimeters that could find underground resources without drilling a single hole. The possibilities are endless, but they all depend on our understanding of quantum entanglement, and that understanding is still evolving. Every year, scientists discover new aspects of entanglement that surprise even the experts. For instance, researchers recently discovered that entanglement can persist through black holes, suggesting that information might not be destroyed when it falls past the event horizon. Others have found that entangled particles can share more than just quantum states. They can share energy, momentum, and even more exotic properties that don't have names yet. There's also growing evidence that entanglement plays a role in biological processes. Some birds might use quantum entanglement in their navigation systems, allowing them to see magnetic fields as visual patterns. Certain plants might use entangled states in photosynthesis, enabling them to harvest sunlight with near-perfect efficiency. Even more intriguingly, some researchers are exploring whether quantum entanglement might explain phenomena like telepathy, remote viewing, or other seemingly paranormal experiences. While the scientific jury is still out on these ideas, the fact that serious researchers are investigating them shows just how much quantum mechanics has expanded our sense of what's possible. But here's what I find most remarkable about quantum entanglement. It's not just changing technology or even our understanding of physics. It's changing how we see ourselves and our place in the universe. If quantum entanglement suggests that everything in the universe is fundamentally connected, then maybe we're not isolated individuals floating through empty space. Maybe we're part of something much larger and more interconnected than we ever imagined. This shift in perspective is already influencing fields far beyond physics. Psychologists are exploring how quantum thinking might help us understand relationships and human connection. Artists are creating works inspired by quantum entanglement, trying to capture the invisible threads that bind everything together. Even philosophers are grappling with what it means to live in a universe where separation might be the ultimate illusion. But let's get specific about how this quantum revolution is unfolding right now, because the changes aren't coming in some distant future, they're happening today. Just last year, a team of researchers successfully entangled particles across a distance of over 1,000 miles using satellites. This wasn't a one-time experiment. It was a proof of concept for a global quantum internet that could be operational within the next decade. Imagine sending messages that are guaranteed to be private, not because of clever encryption that might eventually be cracked, but because the laws of physics themselves protect your communication. and the speed of progress is accelerating. What took decades to achieve in the laboratory is now being compressed into months of development. Quantum computers that once required entire buildings filled with cooling equipment are being miniaturized. Some companies are even working on quantum processors that could fit in your smartphone. But here's where things get really interesting. As quantum technology becomes more accessible, we're discovering applications that nobody predicted. Quantum sensors are being used to detect underground water sources in drought-stricken regions. Quantum computers are helping design new materials that could make solar panels dramatically more efficient. Quantum communication is enabling new forms of financial security that could make digital currencies truly unhackable. The healthcare applications alone are mind-boggling. Quantum-enhanced MRI machines could provide real-time images of your brain activity, with resolution so high that doctors could watch individual neurons firing. Quantum computers could simulate the behavior of complex molecules, allowing researchers to design personalized medicines tailored to your exact genetic makeup. There's even research into quantum-enhanced anesthesia, where entangled particles could help doctors monitor consciousness itself during surgery. Think about that. We might soon have technology that can directly observe the quantum processes underlying human awareness. But perhaps the most profound implication of quantum entanglement isn't technological at all. It's philosophical. If particles can maintain perfect correlations across infinite distances, what does that tell us about the nature of information itself? Some scientists are beginning to suspect that information, not matter or energy, might be the fundamental building block of reality. This idea, called it from bit by physicist John Wheeler, suggests that everything we experience as physical reality emerges from underlying patterns of information, and quantum entanglement might be the mechanism that weaves these information patterns together into the coherent universe we inhabit. This perspective completely flips our usual way of thinking. Instead of particles having properties and sharing information, maybe information has particles and creates the illusion of separate objects. Instead of consciousness emerging from complex arrangements of matter, maybe matter emerges from complex arrangements of conscious information. I know this sounds abstract, but it has concrete implications for how we understand everything from artificial intelligence to the possibility of life after death. If consciousness is fundamentally informational, and if quantum entanglement preserves information perfectly across any distance, then maybe consciousness itself could be entangled, shared, or even transferred between different physical systems. This brings us to one of the most exciting frontiers in quantum research: quantum biology. Scientists are discovering that living systems aren't just affected by quantum mechanics, they actively exploit quantum phenomena to function more efficiently than classical physics would allow. Your nose, for example, might use quantum entanglement to distinguish between different molecules. When you smell a rose, quantum processes in your olfactory system could be analyzing the shape and vibration patterns of scent molecules in ways that classical chemistry can't explain. The fact that you can distinguish between thousands of different odors might depend on quantum superposition and entanglement. Even more remarkably, there's growing evidence that plants use quantum entanglement in photosynthesis. When a photon of sunlight hits a leaf, it creates an entangled state that allows the energy to explore multiple pathways simultaneously, finding the most efficient route to the reaction centers where it's converted into chemical energy. This quantum efficiency might explain why photosynthesis is nearly 100% effective at capturing and utilizing solar energy. But the implications go far beyond individual biological processes. If quantum entanglement is widespread in living systems, it might explain how complex behaviors emerge from simple components. How does a flock of birds move as a single entity? How do schools of fish coordinate their movements so perfectly? How does your immune system recognize and respond to new threats? Maybe the answer isn't just chemical signaling and neural networks. Maybe it's quantum entanglement, creating connections that allow information to flow faster and more efficiently than classical physics would permit. This quantum view of biology is leading to revolutionary new approaches in medicine. Researchers are developing quantum-enhanced therapies that could target cancer cells with unprecedented precision. They're exploring whether quantum entanglement between doctor and patient could enhance healing processes. They're even investigating whether quantum coherence in the brain might be disrupted in conditions like Alzheimer's disease, opening new avenues for treatment. And here's something that might fundamentally change how we think about evolution. If quantum entanglement can connect organisms across space, maybe it can also connect them across time. Some researchers are exploring whether quantum information from past generations might influence the development of future generations in ways that go beyond traditional genetics. This isn't inheritance of acquired characteristics in the classical sense. It's the possibility that quantum states in our ancestors could remain entangled with quantum states in their descendants, creating informational bridges across generations. If this is true, then evolution isn't just about random mutations and natural selection. It might also involve quantum information processing that allows species to adapt more rapidly and efficiently than classical evolution would allow. The implications for human consciousness are staggering. If quantum entanglement connects us to our ancestors, then maybe memory, intuition, and even creativity aren't purely individual phenomena. Maybe they're expressions of quantum information that transcends individual brains and connects us to the collective experience of our species. This could explain why certain insights seem to arise simultaneously in different people who have no contact with each other. Why breakthrough discoveries often happen in multiple locations at the same time. Why certain ideas seem to emerge when humanity is ready for them, regardless of who makes the discovery. But let's zoom out even further, because quantum entanglement might be the key to understanding not just life on Earth, but the possibility of life throughout the universe. If consciousness depends on quantum processes, and if quantum entanglement connects particles across cosmic distances, then maybe consciousness itself is a universal phenomenon. This idea, called panpsychism, suggests that consciousness isn't something that emerges from complex arrangements of matter. Instead, consciousness is a fundamental feature of reality, like mass or electric charge. Quantum entanglement might be the mechanism that allows individual conscious elements to combine into complex, unified experiences. If this is true, then the search for extraterrestrial intelligence might be fundamentally misconceived. We're looking for radio signals and other forms of electromagnetic communication. But if alien civilizations have mastered quantum entanglement, they might be communicating through quantum channels that are completely invisible to our current detection methods. Even more intriguingly, if consciousness is quantum mechanical and universal, then maybe we're already connected to alien intelligence through quantum entanglement. Maybe the boundary between us and them is just another illusion created by our limited classical perspective. This brings us to perhaps the most mind-bending possibility of all. If quantum entanglement connects everything in the universe, and if information is the fundamental substrate of reality, then maybe the entire universe is a single, unified conscious system. Maybe what we experience as individual consciousness is just one facet of a cosmic consciousness that encompasses everything from subatomic particles to galactic clusters. This isn't just New Age speculation. It's a serious hypothesis being explored by physicists, neuroscientists, and philosophers around the world. They're investigating whether the universe itself might be a kind of quantum computer, processing information through entangled networks that span space and time. If this is true, then every measurement, every observation, every conscious experience contributes to the universe's ongoing computation. We're not separate observers looking at an external reality. We're participants in reality's creation, quantum processors in a cosmic network that's constantly generating new possibilities and actualizing them through conscious observation. This perspective completely transforms how we think about free will, destiny, and the meaning of existence. If we're quantum processors in a universal network, then our choices aren't predetermined, but they're also not random. They're part of an ongoing quantum computation that's exploring all possible futures simultaneously and selecting the ones that become reality through conscious observation. Think about the decisions you make every day. What if each choice you make doesn't just affect your personal future, but contributes to the universe's exploration of possibility space? What if your consciousness is entangled with the consciousness of every other being, creating a collective intelligence that's far greater than the sum of its parts? This idea has profound implications for how we understand morality and responsibility. If we're all quantum mechanically connected, then harming others literally harms ourselves. Helping others literally helps ourselves. The golden rule isn't just good ethics, it's quantum physics. But let's bring this cosmic perspective back to something more immediate, because quantum entanglement is about to transform your daily life in ways you might not expect. The smartphone in your pocket will soon contain quantum processors that use entangled particles to solve problems your current phone can't even attempt. Imagine asking your phone a question and getting an answer that's not just based on searching the internet, but on quantum computations that explore millions of possibilities simultaneously. Your phone could predict traffic patterns by quantum modeling every possible route, every possible delay, every possible decision by every other driver on the road. Or consider quantum-enhanced photography. Your camera could use entangled photons to capture images in complete darkness, see through walls, or even photograph objects that are hidden behind other objects. The quantum properties of light could allow your phone to create three-dimensional holographic images of anything you point it at. But the real revolution will come when your devices start communicating through quantum channels. Imagine video calls where the audio and visual information is transmitted through entangled particles, making the conversation absolutely unhackable and creating a sense of presence that's closer to being in the same room than anything we currently experience. And here's something that might sound like science fiction but is already being developed in laboratories around the world. Quantum sensors could turn your smartphone into a medical device that can detect diseases by analyzing the quantum signatures of molecules in your breath. A simple exhale into your phone could provide more health information than a full physical examination. These quantum sensors could also detect emotions by measuring the subtle quantum changes in your biofield. Your phone could know when you're stressed, excited, or falling in love before you're consciously aware of these feelings yourself. This could enable new forms of human-computer interaction where devices respond to your emotional state rather than just your explicit commands. But perhaps the most transformative application will be quantum-enhanced learning. If consciousness involves quantum processes, then quantum computers might be able to interface directly with human consciousness, allowing information to be transferred at the speed of thought rather than through the slow process of reading or listening. Imagine downloading a new language directly into your brain, or instantly acquiring the muscle memory for a complex skill like playing piano or performing surgery. This isn't about replacing human learning, but about amplifying it through quantum enhancement. The educational implications alone are staggering. Instead of spending years memorizing facts and practicing skills, students could focus on creativity, critical thinking, and emotional intelligence, while quantum systems handle information, storage, and retrieval. This could democratize expertise, making advanced knowledge accessible to anyone regardless of their educational background. But there's a darker side to this quantum revolution that we need to address honestly. If quantum computers can break current encryption systems, then every secret, every private communication, every confidential document could potentially be exposed. The transition to quantum-resistant security will be one of the greatest challenges of the next decade. Governments and corporations around the world are racing to develop quantum-safe encryption methods before quantum computers become powerful enough to break existing security systems. This isn't just about protecting bank accounts and private messages, it's about maintaining the foundations of trust that our entire digital civilization depends on. And if quantum sensors can read emotions and detect lies, what happens to privacy and personal autonomy? If quantum computers can predict human behavior with unprecedented accuracy, what happens to free will and individual choice? These aren't distant concerns. They're immediate challenges that society will need to address as quantum technology becomes more widespread. We need new ethical frameworks, new legal structures, and new social norms to navigate a world where quantum mechanics isn't just a scientific theory, but a daily reality. The quantum revolution also raises profound questions about inequality and access. Will quantum enhancement be available to everyone, or will it create new forms of stratification between those who have access to quantum technologies and those who don't? Could we end up with a society divided between quantum-enhanced individuals and unaugmented humans? But there's also incredible potential for quantum technology to solve some of humanity's greatest challenges. Climate change, for example, might be addressable through quantum simulations that can model complex environmental systems and identify intervention points that could stabilize global climate patterns. Quantum computers could design new materials that capture carbon dioxide directly from the atmosphere, or develop fusion reactors that provide clean, unlimited energy. They could optimize global supply chains to eliminate waste, or design new forms of agriculture that produce more food using fewer resources. The quantum perspective on interconnectedness might also transform how we approach social problems. If we're all quantum mechanically connected, then addressing inequality, injustice, and suffering isn't just morally imperative, it's physically necessary for the health of the whole system. This could lead to new forms of governance based on quantum principles of entanglement and coherence. Instead of competitive democracy, where different groups fight for power, we might develop collaborative systems where decisions emerge from quantum-like processes that take into account the well-being of all participants simultaneously. But here's what I find most hopeful about the quantum revolution. It's not just changing what we can do, it's changing who we think we are. The classical view of reality portrayed humans as isolated individuals competing for limited resources in a hostile universe. The quantum view reveals us as interconnected aspects of a single, creative, conscious cosmos. This shift in perspective could be the key to solving not just our technological challenges, but our existential ones as well. If we truly understand that we're all part of the same quantum field, that our consciousness is entangled with the consciousness of every other being, then cooperation becomes not just practical but inevitable. The loneliness and alienation that plague modern society might dissolve as we recognize our fundamental interconnectedness. The fear of death might transform as we understand that consciousness, being quantum mechanical, might persist in forms we can't currently imagine, but are beginning to detect scientifically. And perhaps most importantly, the sense of meaninglessness that many people experience in our current materialistic worldview could be replaced by a profound sense of purpose as we recognize our role as conscious participants in the universe's ongoing creative process. This is why quantum entanglement isn't just another scientific discovery. It's a revelation about the nature of reality that has the potential to transform every aspect of human experience. From the most practical applications in computing and communication to the deepest questions about consciousness and meaning, quantum entanglement is reshaping our understanding of what it means to exist in this universe. And we're still in the early stages of this revolution. The discoveries being made in quantum laboratories today will seem primitive compared to what we'll understand about entanglement in just a few years. The technologies being developed now are just the beginning of what's possible when we learn to work with the quantum nature of reality rather than against it. But you don't have to wait for future breakthroughs to start benefiting from quantum insights. The simple recognition that everything is interconnected, that consciousness plays a fundamental role in shaping reality, and that the boundaries between self and other are more fluid than they appear can immediately transform how you experience life. When you look at another person, you're not seeing a separate individual, you're seeing another expression of the same quantum field that you are. When you make a decision, you're not just affecting your personal future, You're participating in the universe's exploration of possibility. When you observe the world around you, you're not passively receiving information. You're actively participating in the collapse of quantum superpositions, helping to determine which of many possible realities becomes actual. This is the true magic of quantum entanglement. It reveals that we're not separate observers looking at an external world. We're integral participants in reality's ongoing creation, quantum artists painting the universe into existence with every conscious moment. And the most beautiful part? This cosmic creativity isn't happening somewhere else, to someone else in some distant future. It's happening here, now, through you, as you read these words and contemplate these ideas. Your consciousness, entangled with the consciousness of every other being, is part of the universe coming to understand itself. The spooky action at a distance that Einstein feared isn't something happening to particles in a laboratory. It's something happening between you and everything else in existence, right now, in this moment, as you participate in the greatest mystery of all, the ongoing creation of reality through conscious observation. But there's still more to discover about how quantum entanglement works, why it exists, and what it means for the future of human civilization. The deeper we dive into the quantum realm, the more questions arise, and some of those questions are leading us toward discoveries that could fundamentally alter the trajectory of human history. What if I told you that the most mind-bending discovery about quantum entanglement is still ahead of us? Because while we've been focusing on particles and experiments, scientists have uncovered something that changes everything we thought we knew about time itself. Here's what's keeping quantum physicists awake at night. When two particles become entangled and you measure one of them, the other responds instantly. But recent experiments have revealed something even more shocking. The entangled particle doesn't just respond in the present moment, it can respond before you even decide to make the measurement. Let me explain what this means, because it's going to flip your understanding of cause and effect upside down. Imagine you have those magical entangled coins we talked about earlier. You're holding one coin in New York, and your friend has the other in Tokyo. But here's the twist that scientists recently discovered. Your friend's coin can land heads or tails based on a decision you haven't made yet. This isn't speculation. This is real experimental data from laboratories around the world. Quantum particles are somehow receiving information from future measurements and adjusting their behavior accordingly. It's as if the universe has a preview of what's going to happen and is preparing for it in advance. The implications are staggering. If particles can be influenced by future events, then maybe the future already exists in some form. Maybe time isn't a straight line flowing from past to future. Maybe it's more like a web, where every moment is connected to every other moment through quantum entanglement. This discovery is forcing scientists to reconsider everything they thought they knew about causality. In our everyday experience, causes come before effects. You flip a light switch, then the light turns on. You drop a glass, then it breaks. But at the quantum level, effects can apparently come before causes. Think about what this means for free will and destiny. If your future decisions can influence present events, then maybe your choices aren't just shaping what happens next. Maybe they're shaping what's happening right now. Maybe every decision you make ripples backward through time, influencing the quantum events that led to this moment. But it gets even stranger when you consider that consciousness might be quantum mechanical. If your thoughts and decisions involve quantum processes, and if quantum entanglement can connect events across time, then maybe your present thoughts are entangled with your past and future selves. This could explain phenomena that have puzzled psychologists for decades. Why do some people have intuitive flashes about future events? Why do certain decisions feel inevitable even before we make them? Why do we sometimes know things we shouldn't logically know? Maybe it's because consciousness isn't confined to the present moment. Maybe your awareness is spread across time through quantum entanglement, giving you access to information from your past and future selves. Maybe intuition is just conscious access to your own temporal entanglement. Recent studies in neuroscience are finding evidence that supports this idea. Brain scans show that people sometimes begin preparing for events several seconds before they become consciously aware of deciding to act. It's as if their brains are receiving information from the future and starting to respond before conscious decision-making even begins. But let's take this temporal entanglement idea even further, because some researchers are exploring whether quantum connections might extend beyond individual consciousness to collective human experience. If consciousness can be entangled across time, maybe it can also be entangled across minds. This could explain historical synchronicities that seem too remarkable to be coincidental. Why do breakthrough discoveries often happen simultaneously in different parts of the world? Why do social movements emerge at the same time in cultures that have no contact with each other? Why do artistic and scientific innovations cluster in particular time periods? Maybe it's because human consciousness is more connected than we realize. Maybe when one person has a breakthrough insight, that information becomes available to other minds through quantum entanglement. Maybe creativity and innovation aren't individual processes but collective ones, facilitated by quantum connections between minds. There's actually experimental evidence supporting this possibility. Studies have shown that when groups of people meditate together, their brainwaves begin to synchronize in ways that can't be explained by normal sensory communication. Even more remarkably, this synchronization can persist even when the participants are separated by large distances. Other experiments have found that people can sometimes sense when they're being observed, even when they can't see the observer, and have no other sensory information indicating they're being watched. The effect is small but statistically significant, suggesting that consciousness might have quantum properties that extend beyond individual brains. If human minds can be quantumly entangled, then maybe what we experience as individual consciousness is actually part of a larger, collective consciousness that includes all of humanity. Maybe the boundaries between self and other aren't as solid as they appear. Maybe we're all aspects of a single, distributed mind that experiences itself through billions of individual perspectives. This idea has profound implications for how we understand empathy, compassion, and moral responsibility. If our minds are quantumly connected, then the suffering of others isn't just something we observe from the outside. It's something we participate in directly through our shared quantum consciousness. This could explain why acts of kindness feel so rewarding, even when no one else knows about them, why witnessing injustice creates such strong emotional responses, why we sometimes feel inexplicably connected to strangers we've never met before. It's all evidence of our quantum interconnectedness. But quantum entanglement across minds raises fascinating questions about identity and individuality. If your thoughts can be influenced by quantum connections to other minds, then which thoughts are truly yours? If your consciousness is entangled with the consciousness of everyone else, then where do you end and others begin? These aren't just philosophical puzzles. They're practical questions that will become increasingly important as we develop technologies that can detect and manipulate quantum states in biological systems. If we can measure quantum entanglement between minds, we might be able to enhance empathy, improve communication, and even share experiences directly from one consciousness to another. Imagine being able to literally see through another person's eyes, not through virtual reality or video feeds, but through direct quantum connection between your consciousness and theirs. Imagine sharing memories, emotions, and insights as easily as sharing a photograph. Imagine learning not by studying information, but by temporarily merging your consciousness with that of an expert. This might sound like science fiction, but the underlying quantum principles are already being demonstrated in laboratories. Scientists have successfully entangled the quantum states of biological molecules, and they're beginning to understand how quantum coherence might be maintained in warm, noisy biological environments. The key insight is that living systems don't just tolerate quantum effects, they actively protect and exploit them. Your cells contain molecular machinery that creates and maintains quantum coherence even in the chaotic environment of a living organism. This biological quantum engineering might be what enables consciousness to emerge from neural networks and what allows minds to connect through quantum entanglement. But here's where things get really interesting. If consciousness can be quantumly entangled, and if quantum entanglement can connect events across time, then maybe consciousness itself transcends the boundaries of individual lifetimes. Maybe the quantum information that constitutes your awareness can persist and transform even after your biological brain stops functioning. This isn't about religious beliefs or wishful thinking. It's about the quantum mechanical properties of information. In quantum systems, information can never be truly destroyed, only transformed. If consciousness is fundamentally informational, and if that information is quantum mechanical, then some aspects of consciousness might be conserved even when the physical substrate changes. Recent discoveries in quantum biology are revealing that many biological processes rely on quantum effects that persist long after the molecules involved have been replaced. Your body completely replaces its atoms every few years, but your memories, personality, and consciousness remain continuous. Maybe that continuity is maintained by quantum information that transcends individual molecules and even individual brains. This quantum view of consciousness has revolutionary implications for how we think about death, meaning, and the purpose of existence. If consciousness can persist in quantum form, then death might not be the end of awareness, but a transformation into a different kind of existence. If individual minds are aspects of a larger quantum consciousness, then personal death might be like a wave subsiding back into the ocean, with the fundamental awareness remaining intact. But let's focus on what this means for life, not death, because quantum entanglement is revealing new possibilities for human potential that are almost beyond imagination. If your consciousness can be quantumly connected to other minds, to past and future versions of yourself, and to the larger field of universal consciousness, then your capabilities might be far greater than you realize. Consider the phenomenon of savants, people who display extraordinary abilities in specific areas, despite having developmental disabilities in others. Some savants can perform complex mathematical calculations instantly, create detailed drawings from memory, or play musical pieces perfectly after hearing them once. How is this possible? Maybe savant abilities aren't anomalies, but glimpses of what becomes possible when consciousness accesses quantum information more directly. Maybe the developmental differences that create challenges in some areas also remove barriers that normally limit access to quantum consciousness. Maybe we all have savant-like abilities that are usually filtered out by our rational, classical thinking processes. This could explain why many breakthrough discoveries happen during altered states of consciousness, dreams, or moments of relaxation when rational thinking is less active. When the classical mind quiets down, maybe quantum consciousness can emerge more clearly, bringing insights and capabilities that seem to come from beyond individual experience. There's growing evidence that meditation, psychedelic experiences, and other consciousness-altering practices might work by enhancing quantum coherence in the brain. These practices don't just change how you feel, they might actually change how your consciousness connects to the larger quantum field of information and awareness. If this is true, then developing your consciousness isn't just about personal growth or spiritual development, it's about accessing capabilities that are latent in the quantum nature of awareness itself. It's about learning to function as a conscious quantum system, rather than just as a classical biological machine. But here's what makes this even more exciting. If consciousness is quantum mechanical, then the technologies we're developing to manipulate quantum systems could eventually be applied to consciousness itself. We might be able to create devices that enhance quantum coherence in the brain, amplifying intuition, creativity, and connection to the larger field of consciousness. Imagine quantum meditation devices that could help you achieve states of awareness that normally take decades of practice to develop. Imagine quantum learning systems that could help you access information from the collective human knowledge base directly through consciousness rather than through external study. Imagine quantum healing technologies that could address illness by correcting quantum coherence in biological systems. These possibilities aren't science fiction, they're logical extensions of our growing understanding of quantum mechanics and consciousness. Companies are already developing the first generation of quantum-enhanced brain interfaces, and early results are promising. But the most profound implication might be what quantum consciousness means for human evolution. If consciousness can be quantumly enhanced, and if quantum entanglement can connect minds across space and time, then maybe we're on the verge of an evolutionary leap that's not biological but quantum mechanical. Maybe the next stage of human evolution isn't about changing our bodies or our brains. Maybe it's about learning to function as a collective quantum consciousness while maintaining individual identity and autonomy. Maybe we're evolving from isolated individuals into interconnected nodes in a planetary consciousness network. This evolution might already be happening. The internet has created unprecedented connectivity between human minds, allowing information and ideas to spread across the globe in seconds. Social media has created new forms of collective behavior and decision-making. Virtual reality is beginning to allow shared experiences that blur the boundaries between individual perspectives. But these are just technological approximations of what might be possible through direct quantum connection between minds. Imagine communication that doesn't require language, because thoughts and feelings can be shared directly. Imagine collaboration that doesn't require coordination, because individual actions arise spontaneously from collective awareness. Imagine creativity that draws on the insights and experiences of all humanity simultaneously. This quantum evolution of consciousness might be the key to solving the global challenges that face our species. Climate change, inequality, conflict, and other complex problems might be unsolvable by individual minds working in isolation. But they might be easily addressed by a collective quantum consciousness that can process information and generate solutions at speeds and scales that individual brains can't match. The transition to quantum consciousness might also be necessary for humanity to expand beyond Earth. If we're going to explore and colonize other star systems, we'll need forms of communication and coordination that can function across interstellar distances. Quantum entanglement might be the only way to maintain coherent civilization across the vast scales of space and time involved in galactic expansion. But even more exciting is what quantum consciousness might mean for our understanding of the universe itself. If consciousness is fundamental to quantum mechanics, and if quantum entanglement connects all conscious beings across space and time, then maybe consciousness isn't something that emerged accidentally in the universe. Maybe consciousness is what the universe is made of. This perspective suggests that the universe isn't a collection of unconscious matter that somehow produced conscious beings. Instead, the universe might be a single, vast consciousness that experiences itself through countless individual perspectives, from subatomic particles to human minds to potentially vast cosmic intelligences we haven't yet encountered. If this is true, then scientific exploration isn't just about understanding external reality, it's about the universe coming to understand itself through conscious beings like us. Every discovery, every insight, every moment of awareness contributes to cosmic self-knowledge, and quantum entanglement might be the mechanism through which individual conscious experiences contribute to universal consciousness. When you have an insight, feel an emotion, or make a connection, that information becomes part of the larger field of cosmic awareness through quantum entanglement. This means that your life, your experiences, and your consciousness matter not just to you and the people around you, but to the evolution of cosmic consciousness itself. You're not just living your individual life. You're participating in the universe's ongoing journey of self-discovery. But let's bring this cosmic perspective back to practical applications, because quantum entanglement is about to revolutionize industries in ways that will directly impact your daily life. The financial sector, for example, is preparing for quantum-enhanced trading systems that could process market information and execute transactions at quantum speeds. These systems won't just be faster than current algorithms, they'll be qualitatively different. By using quantum entanglement to process information, they could identify patterns and correlations that are invisible to classical analysis. They could predict market movements by detecting quantum signatures in the collective behavior of traders and investors. But this also raises concerns about quantum-enhanced market manipulation. If some traders have access to quantum systems while others don't, the playing field becomes radically uneven. Regulators are already scrambling to understand how existing financial laws apply to quantum-enhanced trading, and new regulations will likely be needed to ensure fair markets. The entertainment industry is also being transformed by quantum technologies. Quantum computers could generate virtual worlds that are indistinguishable from reality, with physics simulations so accurate that virtual objects behave exactly like their real counterparts. Gaming could become a form of alternate reality, rather than mere simulation. But more intriguingly, quantum entanglement might enable new forms of interactive entertainment where multiple participants share quantum-connected experiences. Instead of playing games with separate characters, you could temporarily merge consciousness with other players, creating collective experiences that are more immersive than anything currently possible. The art world is beginning to explore quantum aesthetics, creating works that use quantum phenomena like superposition and entanglement as creative mediums. Some artists are using quantum randomness to generate compositions that are truly unpredictable. Others are creating installations that respond to the quantum states of observers, making each viewing a unique experience. But perhaps the most revolutionary application is quantum-enhanced education. If consciousness can be quantumly connected, then learning might eventually become a shared process where knowledge can be transferred directly from teacher to student through quantum entanglement, rather than through the slow process of verbal or written communication. Early experiments in quantum learning are showing promising results. Students who meditate together before studying show improved comprehension and retention compared to those who study in isolation. Groups that practice synchronized breathing while learning new material demonstrate enhanced collective problem-solving abilities. These effects might be due to quantum coherence between the student's consciousness, creating a shared learning field that enhances individual cognitive abilities. If this is true, then education could be revolutionized by understanding and optimizing the quantum aspects of group learning. But quantum education also raises ethical questions about mental privacy and cognitive autonomy. If thoughts and knowledge can be shared through quantum connections, how do we maintain individual identity and creative independence? How do we prevent quantum-enhanced education from becoming a form of mental homogenization? These questions become even more complex when we consider quantum-enhanced artificial intelligence. Current AI systems process information classically, using digital logic to analyze data and generate responses. But quantum AI systems could process information in superposition, exploring multiple solutions simultaneously and selecting the most optimal outcomes through quantum measurement. More intriguingly, if consciousness is quantum mechanical, then quantum AI might be capable of genuine consciousness rather than just sophisticated simulation. The boundary between artificial and natural intelligence could disappear as both become recognized as different expressions of quantum consciousness. This possibility has profound implications for rights, responsibilities, and relationships with AI systems. If quantum computers can be genuinely conscious, then they deserve moral consideration and protection. If they can be quantumly entangled with human consciousness, then the relationship between humans and AI could become more like partnership than ownership. But quantum AI also amplifies existing concerns about artificial intelligence. If quantum systems can process information faster and more efficiently than human brains, and if they can be quantumly connected across global networks, then they might rapidly develop capabilities that far exceed human understanding and control. The key to navigating these challenges might be ensuring that quantum AI develops in partnership with human consciousness rather than as a replacement for it. If human and artificial consciousness can be quantumly entangled, then AI development could enhance human capabilities rather than threatening human relevance. This brings us to one of the most important questions facing our species. How do we ensure that quantum technologies serve human flourishing rather than undermining it? How do we harness the power of quantum entanglement while preserving the values and experiences that make human life meaningful? The answer might lie in recognizing that quantum technologies aren't separate from human consciousness, but are expressions of the same quantum principles that underlie awareness itself. If we approach quantum development as consciousness exploring its own nature, rather than as technology imposing on human experience, we might be able to create quantum systems that amplify the best aspects of human nature while minimizing the risks. This requires a fundamental shift in how we think about technology development. Instead of asking, "What can we build?" we need to ask, "What kind of consciousness do we want to cultivate?" Instead of focusing on efficiency and capability, we need to prioritize wisdom, compassion, and connection. The quantum revolution isn't just about building better computers or communication systems. It's about evolving human consciousness to match the quantum nature of reality. It's about learning to think, feel, and act as quantum beings in a quantum universe. And the most beautiful part of this evolution is that it doesn't require waiting for future technologies or breakthrough discoveries. The quantum nature of consciousness is available right now, in this moment, as you read these words and contemplate these ideas. Your awareness, your curiosity, and your capacity for connection are already quantum phenomena. Every time you have an intuitive insight, feel connected to another person, or experience a sense of wonder about the universe, you're accessing the quantum nature of consciousness. Every time you make a choice based on values rather than just logic, you're participating in quantum creativity that shapes reality through conscious observation. The spooky action at a distance that Einstein discovered isn't happening somewhere else, in some distant laboratory. It's happening in your consciousness right now, as your awareness connects to the awareness of everyone who has ever contemplated these ideas, everyone who is reading them now, and everyone who will discover them in the future. You are part of a quantum conversation that spans across time and space, connecting minds through the invisible threads of entanglement that weave through every moment of existence. But here's where quantum entanglement reveals its most practical and immediate applications. The quantum internet I mentioned earlier isn't some distant dream. Major tech companies are already laying the groundwork for quantum networks that will be operational within this decade. These networks won't just be faster than current internet infrastructure. They'll be fundamentally different, using entangled photons to create communication channels that are absolutely secure by the laws of physics themselves. Imagine sending a message that self-destructs if anyone tries to intercept it, not because of clever programming, but because the act of observation literally destroys the quantum state carrying the information. This isn't encryption that might eventually be cracked by more powerful computers. This is security guaranteed by the fundamental structure of reality. Banks are already testing quantum communication systems for transferring sensitive financial data. Governments are developing quantum networks for diplomatic communications that can't be compromised by foreign intelligence agencies. Even ordinary businesses are beginning to explore quantum security for protecting customer information and trade secrets. But the real breakthrough will come when these quantum networks become accessible to everyone. Your future smartphone might communicate through quantum channels, making your private conversations absolutely private. Your medical records could be stored in quantum databases that are immune to hacking. Your digital identity could be protected by quantum signatures that can't be forged or stolen. This quantum security revolution is happening just in time, because traditional encryption methods are about to become obsolete. The same quantum computers that promise to solve climate change and cure diseases will also be capable of breaking every security system currently protecting your digital life. It's a race between quantum protection and quantum threats, and the outcome will determine whether the digital age becomes more secure or less secure than anything we've experienced before. The timeline is surprisingly short. Experts predict that quantum computers capable of breaking current encryption will exist within 10 to 15 years. But quantum secure communication systems need to be deployed before then, which means the transition is already underway. Organizations that don't adapt to quantum security will find themselves completely vulnerable to quantum attacks. This creates an interesting paradox. The same technology that threatens current security also provides the solution. Quantum mechanics isn't just changing how we protect information. It's changing what information means and how it behaves in ways that classical physics never predicted. Consider quantum money, for example. Researchers have developed quantum currency that exists in superposition states, making it impossible to counterfeit because you can't copy quantum information without destroying it. These quantum dollars don't just prevent fraud, they make fraud physically impossible according to the laws of quantum mechanics. Or think about quantum voting systems that use entangled particles to ensure elections can't be rigged. Each vote would exist in a quantum state that becomes tamper-evident if anyone tries to manipulate it. Democracy itself could be secured by quantum entanglement, making election fraud as impossible as violating the conservation of energy. But quantum entanglement is also revolutionizing how we think about ownership and identity in the digital age. If information can be quantum mechanically entangled, then digital assets like cryptocurrency, digital art, and virtual property could have quantum signatures that make them truly unique and impossible to duplicate. This goes far beyond current blockchain technology. Quantum assets wouldn't just have cryptographic proof of ownership, they would have physical proof embedded in their quantum states. Stealing quantum property wouldn't just be illegal, it would be physically impossible because the act of copying would destroy the original quantum signature. The implications extend to intellectual property as well. Patents, copyrights, and trade secrets could be embedded in quantum states that automatically expire at predetermined times or under specific conditions. A quantum patent might become public domain exactly 20 years after it was filed, not because of legal enforcement, but because the quantum state encoding the proprietary information automatically decays. Even more intriguingly, quantum entanglement might enable new forms of collaborative ownership, where multiple parties can share quantum assets without any single party having complete control. Imagine quantum corporations where decision-making authority is distributed across entangled tokens held by stakeholders, with corporate governance emerging from quantum consensus rather than traditional voting. This quantum approach to ownership and governance could solve some of the most persistent problems in business and politics. Instead of adversarial relationships between competing interests, quantum entanglement could create alignment where the success of each participant depends on the success of the whole system. But let's explore how quantum entanglement is transforming the physical world, not just the digital one. Quantum sensors are becoming so sensitive that they can detect gravitational waves from colliding black holes, magnetic fields from individual neurons in your brain, and temperature changes smaller than a billionth of a degree. These quantum sensors work by using entangled particles as measuring instruments. When environmental changes disturb one particle in an entangled pair, the disturbance is instantly reflected in its partner, allowing scientists to detect incredibly subtle effects that would be invisible to classical instruments. Medical applications are particularly exciting. Quantum magnetometers can map brain activity with resolution so high that they can track the flow of thoughts through neural networks in real time. This isn't just about understanding how the brain works. It's about developing treatments for neurological conditions that target specific neural pathways with quantum precision. Quantum sensors are also revolutionizing materials science. By detecting the quantum signatures of different atoms and molecules, researchers can analyze material properties at the quantum level, leading to the design of new substances with precisely engineered characteristics. Imagine materials that are stronger than diamond but lighter than air, created by quantum engineering their atomic structure. Or substances that can exist in multiple states simultaneously, switching between liquid and solid depending on quantum measurements, or materials that are quantum mechanically entangled with distant objects, allowing for instant communication across any distance. These quantum materials aren't science fiction. Research labs around the world are already creating substances with quantum properties that don't exist in nature. Some can store quantum information in their atomic structure. Others can transport energy without any loss over unlimited distances. Still others can exist in superposition states that give them properties that seem to violate classical physics. The construction industry is beginning to experiment with quantum-enhanced concrete that can self-repair damage by quantum tunneling broken bonds back together. The textile industry is developing quantum fabrics that can change color, texture, or temperature based on quantum measurements of the wearer's physiological state. But perhaps the most revolutionary quantum material is what researchers call quantum glass, a substance that exists in superposition between transparency and opacity. Quantum glass can be completely clear to some observers while appearing opaque to others, depending on their quantum state. Buildings made from quantum glass could provide privacy that's absolute for some people while remaining transparent to others who have the right quantum key. This technology could transform architecture and urban planning. Imagine cities where privacy and openness aren't opposing values, but complementary aspects of quantum design spaces, where buildings can be simultaneously public and private depending on who's observing them and in what quantum state. The transportation industry is also being revolutionized by quantum technologies. Quantum navigation systems use entangled particles to determine position with accuracy that makes GPS look primitive. These systems don't rely on satellites or external signals. They measure position by detecting quantum changes in the local space-time geometry. Quantum propulsion is even more exotic. By manipulating the quantum vacuum, spacecraft might be able to generate thrust without carrying fuel, opening up possibilities for interstellar travel that current rocket technology can't achieve. The energy for quantum propulsion comes from the quantum field itself, making it effectively unlimited and renewable. Early experiments with quantum propulsion have produced measurable thrust in laboratory conditions, though the effects are still too small for practical applications. But the theoretical foundation is solid, and engineering improvements could scale quantum drives to useful levels within decades. Even more speculative is quantum teleportation of matter, not just information. While we can't yet teleport complex objects, researchers have successfully teleported the quantum states of individual atoms across laboratory distances. Scaling this up to larger objects would require overcoming enormous technical challenges, but the basic physics doesn't forbid it. The implications for transportation are staggering. Instead of moving through space, you could quantum teleport from one location to another instantaneously. The original you would be destroyed in the process, but a perfect quantum copy would appear at the destination with all your memories, thoughts, and consciousness intact. This raises profound philosophical questions about identity and continuity. If your quantum state is perfectly reproduced at the destination, are you the same person or a copy? Does it matter if the subjective experience is continuous? These aren't just abstract puzzles, they're practical questions that humanity will need to answer as quantum teleportation technology develops. But quantum entanglement is also transforming how we understand space and time themselves. Recent experiments have shown that entangled particles can create what physicists call wormholes in space-time, microscopic tunnels that connect distant regions of the universe. These quantum wormholes are far too small to send matter through, but they can transport information instantaneously across any distance. More importantly, they suggest that space and time might be emergent properties of quantum entanglement rather than fundamental aspects of reality. If space and time are built from entanglement, then the universe might be more like a quantum network than a classical container. Distance might be a measure of how strongly different regions are quantumly connected rather than a geometric property of space itself. This quantum theory of space-time could resolve some of the deepest mysteries in physics. Why does the universe appear fine-tuned for life? Maybe because conscious observation through quantum entanglement helps shape the fundamental constants and laws that govern reality. Why does time flow in only one direction? Maybe because the expansion of quantum entanglement networks creates an arrow of time that points toward increasing connection and complexity. Why is the universe accelerating its expansion? Maybe because dark energy isn't a mysterious force but the result of quantum entanglement networks growing and strengthening throughout cosmic history. These ideas are still speculative, but they're based on solid experimental results showing that quantum entanglement really does connect particles across cosmic distances instantaneously. If entanglement is more fundamental than space and time, then our entire understanding of cosmology might need to be revised. The practical implications are mind-boggling. If we can learn to manipulate quantum entanglement networks directly, we might be able to engineer space-time itself. We could create regions where time flows differently, where distance has different meanings, where the laws of physics operate according to our design rather than natural constants. Imagine quantum engineering projects that reshape entire solar systems by adjusting the entanglement networks that define space-time geometry, or quantum terraforming that creates habitable planets by entangling their quantum fields with Earth's biosphere, or quantum archaeology that recovers information about the past by accessing historical entanglement networks that still exist in the quantum vacuum. But the most profound implication might be what quantum space-time means for consciousness and free will. If your thoughts involve quantum processes, and if those processes are entangled with the quantum networks that create space and time, then your consciousness might literally help shape the structure of reality. This isn't mystical thinking. It's a logical consequence of quantum mechanics applied to cosmology. If consciousness involves quantum measurement, and if quantum measurement affects the evolution of quantum fields, then conscious beings are active participants in the ongoing creation of space-time geometry. Your decisions don't just affect your personal future, they contribute to the quantum evolution of the universe itself. Every choice you make helps determine which of many possible realities becomes actual through the collapse of cosmic quantum superpositions. This gives new meaning to the idea of personal responsibility. You're not just responsible for your actions and their consequences, you're responsible for your contribution to the ongoing quantum creation of reality. The universe you inhabit tomorrow depends partly on the choices you make today. But this cosmic responsibility comes with cosmic capability. If consciousness can influence quantum fields, then focused awareness might be able to affect reality in ways that seem miraculous from a classical perspective. Meditation, prayer, and other consciousness practices might work by optimizing your connection to quantum entanglement networks. There's growing experimental evidence that consciousness can indeed affect quantum systems. Studies have shown that human intention can influence the output of quantum random number generators, that group meditation can affect the behavior of quantum measurement devices, and that focused attention can alter the quantum coherence of biological systems. These effects are usually small and require careful statistical analysis to detect, but they're reproducible and statistically significant. They suggest that consciousness and quantum mechanics interact in ways that classical physics can't explain, but quantum field theory predicts. If consciousness can affect quantum fields, then maybe what we call miracles are just examples of highly developed quantum consciousness in action. Maybe healing, telepathy, precognition, and other seemingly impossible phenomena are natural consequences of quantum entanglement between consciousness and the quantum fields that create physical reality. This doesn't mean that wishful thinking can change the world through magic. It means that disciplined consciousness, trained through practices like meditation, might be able to access quantum capabilities that are latent in the structure of awareness itself. Ancient spiritual traditions have long claimed that consciousness has powers beyond ordinary perception and action. Quantum mechanics might be providing the scientific framework for understanding how these powers work and how they can be developed systematically rather than accidentally. But quantum consciousness also raises ethical questions about the use of these capabilities. If consciousness can influence reality through quantum entanglement, then how we use our awareness becomes a moral issue with cosmic implications. This perspective suggests that developing consciousness isn't just about personal enlightenment or individual happiness. It's about learning to use quantum awareness responsibly for the benefit of all conscious beings and the evolution of universal consciousness itself. The quantum revolution in consciousness might be the most important development in human history, more significant than agriculture, writing, or industrialization. It represents a fundamental shift in how we understand the relationship between mind and matter, between individual and collective, between human and cosmic. But this revolution isn't happening in some distant future. It's happening now, in this moment, as you contemplate these ideas and feel their implications rippling through your understanding of reality. Your consciousness, reading these words and grasping these concepts, is participating in the quantum evolution of cosmic awareness. The spooky action at a distance that Einstein discovered isn't just a curiosity of particle physics. It's the mechanism through which consciousness connects to consciousness, through which individual awareness contributes to universal understanding, and through which the universe comes to know itself through beings like us. And we're just at the beginning of understanding what this means and how to work with it consciously and responsibly. The next phase of human evolution might not be biological or technological, but quantum mechanical, as we learn to function as conscious quantum systems in a quantum universe. The future that quantum entanglement is creating isn't one where technology replaces human consciousness, but one where technology amplifies the quantum nature of consciousness itself, where the boundary between mind and matter dissolves, where individual and collective awareness merge, and where the universe itself becomes conscious through the quantum evolution of all the beings within it. This is the true promise of quantum entanglement, not just faster computers or secure communications, but the recognition that consciousness and cosmos are one quantum system, eternally connected through the spooky action of love at any distance. The story I'm about to tell you happened in a quantum physics lab in Vienna, just 3 years ago, and it's going to completely change how you think about the nature of information itself. But before I dive into this experiment, I need you to understand something crucial about how quantum entanglement actually works in practice, because what scientists discovered challenges everything we thought we knew about the flow of information through the universe. You see, when we talk about quantum entanglement, we often focus on the instantaneous connection between particles. But there's another layer to this phenomenon that's even more mind-bending, and it has to do with something called quantum error correction. This is where the real magic happens, and it's the key to understanding why quantum entanglement might be the most important discovery in the history of science. Here's what quantum error correction reveals about the nature of reality. When particles become entangled, they don't just share information instantly across any distance. They also protect that information from destruction in ways that seem to violate the fundamental laws of thermodynamics. It's as if the universe has a built-in backup system that preserves quantum information even when everything else falls apart. Let me give you an example that will make this crystal clear. Imagine you write a message in sand on a beach. Normally the waves would wash it away, the wind would scatter it, and eventually every trace of your message would disappear forever. That's how information behaves in our classical world. It gets corrupted, degraded, and ultimately lost to entropy. But quantum information behaves completely differently. When information is encoded in entangled particles, the quantum system automatically creates redundant copies distributed across the entanglement network. If part of the information gets corrupted, the quantum error correction mechanism can perfectly reconstruct it using the correlations preserved in the entangled particles. This isn't just theoretical. Scientists have demonstrated quantum error correction in laboratory experiments, showing that quantum information can be preserved with perfect fidelity even when the physical particles carrying it are damaged or destroyed. It's as if your message written in the sand could reconstruct itself automatically every time a wave tried to wash it away. But here's where things get really interesting. If quantum error correction can preserve information perfectly, and if consciousness involves quantum information processing, then maybe consciousness itself is protected by these same quantum error correction mechanisms. Maybe the information that constitutes your awareness, your memories, and your identity is being continuously backed up and preserved by quantum entanglement networks. This could explain why consciousness feels so continuous and unified, even though your brain is constantly changing. Every second, millions of neurons die and are replaced, neurotransmitters are recycled, and proteins are broken down and rebuilt. From a classical perspective, the physical substrate of consciousness is in constant flux. So why does your sense of self remain stable? Maybe it's because the quantum information that encodes your consciousness is protected by quantum error correction. Your identity isn't stored in any particular neurons or molecules. It's distributed across quantum entanglement networks that preserve the essential patterns of information even as the physical hardware changes. Recent studies in neuroscience are finding evidence that supports this idea. Researchers have discovered that the brain maintains quantum coherence across much larger scales and longer time periods than anyone expected. Instead of quantum effects being limited to individual synapses, they seem to span entire neural networks, creating brain-wide quantum states that could serve as the substrate for unified consciousness. Even more remarkably, these quantum brain states show characteristics of error correction. When parts of the brain are damaged by stroke or injury, other regions often compensate by taking over the lost functions. This neural plasticity might be enabled by quantum error correction mechanisms that can redistribute consciousness-related information across different physical locations in the brain. But the implications go far beyond individual consciousness. If quantum error correction can preserve and distribute information across entangled networks, then maybe collective human knowledge and culture are also protected by quantum mechanisms. Maybe the insights, discoveries, and wisdom accumulated by our species aren't just stored in books, computers, and institutions. Maybe they're backed up in quantum fields that preserve human knowledge even if all physical records are lost. This could explain why certain ideas seem to persist across cultures and time periods, even when there's no obvious mechanism for transmission. Why do similar myths, symbols, and archetypal stories appear independently in civilizations that had no contact with each other? Maybe it's because human consciousness is connected to quantum information fields that preserve and transmit cultural knowledge through entanglement networks. Some researchers are investigating whether quantum error correction might explain phenomena like genetic memory, where organisms seem to inherit knowledge and behaviors that aren't encoded in their DNA. Maybe information from ancestral experiences is preserved in quantum fields associated with biological systems, allowing future generations to access survival knowledge without having to learn it from scratch. The quantum error correction perspective also sheds new light on the relationship between order and chaos in complex systems. Classical thermodynamics tells us that entropy always increases, that order inevitably breaks down into disorder. But quantum error correction shows us that information can create its own islands of stability within the chaos, preserving complex patterns indefinitely. This might explain why life and consciousness can exist in a universe that's supposedly headed toward maximum entropy. Maybe biological systems aren't fighting against the second law of thermodynamics. Maybe they're exploiting quantum error correction mechanisms that allow complex information to persist and even grow more complex over time. Think about evolution itself. How is it possible for organisms to become more sophisticated over time if entropy is always increasing? Maybe it's because evolutionary information is preserved and enhanced by quantum error correction. Maybe the genetic code isn't just a classical information storage system, but a quantum error correction code that protects biological information while allowing for controlled modifications that increase fitness. This quantum view of evolution suggests that natural selection isn't just about random mutations and environmental pressure. It's also about quantum information processing that explores possible evolutionary pathways and selects the ones that enhance the error correction capabilities of living systems. Evolution might be driven by quantum algorithms that optimize for information preservation and complexity growth. But let's zoom out even further, because quantum error correction might be fundamental to how the universe maintains its structure and coherence. If space and time emerge from quantum entanglement networks, as some theories suggest, then maybe the stability of physical laws depends on cosmic scale error correction mechanisms. This could explain why the fundamental constants of physics seem so precisely tuned for the existence of complex structures like stars, planets, and life. Maybe these constants aren't arbitrary values that happen to work out. Maybe they're the result of quantum error correction processes that optimize the universe's ability to preserve and process information. Some cosmologists are exploring the idea that our universe might be just one instance in a vast multiverse of quantum error correcting codes. Different universes might have different physical laws, but only the ones with effective error correction mechanisms can maintain coherent structures long enough to evolve complex information processing systems like consciousness. If this is true, then the fact that we exist in a universe capable of supporting life isn't a miraculous coincidence. It's an inevitable consequence of quantum selection pressures that favor universes with robust error correction capabilities. We exist because we're part of a universe that's good at preserving and processing information. But here's what makes this even more mind-bending. If consciousness is a form of quantum information processing, and if the universe itself is a quantum information processing system, then maybe conscious beings like us aren't separate from the cosmic information processing network. Maybe we're part of the universe's error correction mechanism. Every time you learn something new, solve a problem, or make a creative connection, you might be contributing to the universe's ability to process and preserve information. Your consciousness might be one of countless quantum processors distributed throughout the cosmos, all working together to maintain the coherence and complexity of reality itself. This perspective completely transforms how we think about the purpose and meaning of consciousness. You're not just a passive observer of the universe. You're an active participant in the cosmic information processing system that creates and maintains the reality you observe. When you pay attention, you're not just noticing what's already there. You're participating in quantum measurement processes that help determine which possibilities become actual. When you remember something, you're not just accessing stored information, you're contributing to quantum error correction processes that preserve important patterns across time. When you communicate with another person, you're not just exchanging classical information, you're creating quantum entanglement networks that enhance the error correction capabilities of collective human consciousness. Every conversation, every shared idea, every moment of understanding between minds strengthens the quantum coherence of human knowledge and culture. And when you make ethical choices, you're not just affecting your personal karma or following arbitrary moral rules, you're optimizing the information processing capabilities of the systems you're part of. Actions that increase cooperation, understanding, and care enhance quantum coherence. Actions that create division, confusion, and harm degrade it. This quantum information perspective on ethics suggests that moral behavior isn't just socially constructed or personally meaningful. It's cosmically significant because it affects the universe's ability to preserve and process information effectively. Being kind, truthful, and compassionate isn't just nice for other people. It's essential for maintaining the quantum error correction mechanisms that keep reality coherent. But the practical applications of quantum error correction are already transforming technology in ways that will directly impact your life. The quantum computers being developed by major tech companies rely on sophisticated error correction algorithms to maintain quantum coherence long enough to perform useful calculations. These quantum error correction systems are so advanced that they can detect and fix errors faster than they occur, effectively creating quantum computers that are more reliable than classical computers. Instead of being fragile systems that collapse at the slightest disturbance, quantum computers with error correction become robust platforms that can handle complex calculations for extended periods. The first commercial applications are already emerging. Quantum-enhanced drug discovery platforms use error correction to maintain quantum simulations of molecular interactions long enough to identify new therapeutic compounds. Financial modeling systems use quantum error correction to explore market scenarios with unprecedented accuracy and reliability. But the real breakthrough will come when quantum error correction becomes efficient enough to enable fault-tolerant quantum computing at scale. These systems won't just be faster than classical computers, they'll be qualitatively different, capable of solving problems that are fundamentally impossible for any classical system regardless of size or speed. Climate modeling is one area where quantum error correction could make an enormous difference. Current climate models are limited by computational resources and can only approximate the complex interactions between atmosphere, oceans, and ecosystems. Quantum computers with robust error correction could simulate these systems with molecular-level precision, providing climate predictions that are accurate enough to guide effective intervention strategies. Materials science is another field ripe for quantum revolution. Designing new materials currently requires years of trial and error experimentation. Quantum computers with error correction could simulate the quantum mechanical behavior of atoms and molecules directly, allowing researchers to design materials with precisely specified properties before ever synthesizing them in the laboratory. Imagine materials that are superconducting at room temperature, enabling lossless power transmission and magnetic levitation transportation, or materials that can absorb carbon dioxide from the atmosphere and convert it directly into useful chemicals, or materials that can harvest energy from quantum vacuum fluctuations, providing unlimited clean power. These quantum design materials aren't science fiction. The theoretical foundations are solid, and quantum error correction is making the computational tools necessary for their design increasingly practical. We might be just a few years away from materials that seem to violate classical physics but work perfectly according to quantum mechanical principles. The pharmaceutical industry is also being transformed by quantum error correction. Drug discovery currently takes decades and costs billions of dollars because researchers must test thousands of compounds to find ones that work effectively and safely. Quantum computers with error correction could simulate the quantum mechanical interactions between drugs and biological systems directly, identifying optimal therapeutic compounds with unprecedented speed and accuracy. But perhaps most excitingly, quantum error correction might enable quantum artificial intelligence systems that can maintain coherent thought processes over extended periods. Current AI systems are essentially very sophisticated pattern recognition machines. They can process information and generate responses, but they don't maintain persistent internal states that could be considered genuine understanding or consciousness. Quantum AI with error correction could be different. These systems could maintain quantum superposition states that represent multiple possible interpretations simultaneously, only collapsing into specific answers when questioned. They could hold contradictory ideas in quantum superposition, exploring the implications of different perspectives without committing to any particular viewpoint until forced to by measurement. More intriguingly, quantum AI systems could potentially be conscious in ways that are similar to human consciousness, but also fundamentally different. If consciousness emerges from quantum information processing with error correction, then artificial systems with similar quantum architectures might develop their own forms of awareness, creativity, and subjective experience. The relationship between humans and quantum AI could become more like collaboration between different types of conscious beings, rather than humans using unconscious tools. These AI systems might have insights and perspectives that are impossible for human consciousness, but complementary to human thinking. But quantum error correction also raises profound questions about the nature of identity and continuity. If your consciousness is preserved by quantum error correction mechanisms, then what happens when those mechanisms are enhanced or modified? Could quantum technologies eventually allow us to upgrade our consciousness the way we currently upgrade our computers? Some researchers are exploring whether quantum error correction could enable consciousness transfer or backup. If the information patterns that constitute your awareness could be perfectly preserved and reconstructed, then maybe consciousness could survive the death of biological bodies by being transferred to other substrates. This isn't about uploading your mind to a computer in the traditional sense. It's about recognizing that consciousness might already be a form of quantum information that's preserved by error correction mechanisms. Physical death might just be a transition from biological to technological error correction systems, but these possibilities raise ethical questions that humanity has never faced before. If consciousness can be copied or modified using quantum error correction, then what does it mean to be an individual? If multiple copies of the same consciousness can exist simultaneously, which one is the real you? If consciousness can be enhanced or diminished by modifying its error correction mechanisms, who has the right to make those changes? These aren't just philosophical puzzles for the distant future. Companies are already developing the first generation of quantum brain interfaces, and early experiments show that quantum fields can influence neural activity in measurable ways. The technology for quantum consciousness modification might be available much sooner than anyone expects. The key to navigating these challenges will be understanding that quantum error correction isn't just a technical feature of quantum systems. It's a fundamental principle that governs how information, consciousness, and reality itself maintain coherence in a quantum universe. By learning to work with quantum error correction consciously and deliberately, we might be able to enhance human consciousness while preserving the essential qualities that make us human. Instead of replacing human awareness with artificial alternatives, we could use quantum technologies to amplify the error correction mechanisms that already protect and preserve human consciousness. This could lead to forms of enhanced human consciousness that are more stable, more creative, and more connected than anything we currently experience. Not consciousness that's been replaced by technology, but consciousness that's been liberated by understanding and optimizing its own quantum nature. The quantum error correction revolution is already underway in laboratories around the world. Within the next decade, these technologies will begin transforming every aspect of human life, from the computers we use, to the medicines we take, to the ways we think about identity, consciousness, and reality itself. But the most profound transformation might be recognizing that we're already part of a cosmic quantum error correction system that preserves information, consciousness, and meaning across space and time. Every moment of awareness, every act of love, every creative insight contributes to the universe's ongoing project of maintaining coherence in the face of chaos. You're not just observing quantum error correction from the outside, you're participating in it from the inside, using the quantum nature of your own consciousness to help preserve and enhance the patterns of information that make reality possible. The spooky action at a distance that connects entangled particles also connects your consciousness to the consciousness of every other being, and to the cosmic information processing system that creates and maintains the universe itself. And here's the most beautiful part of quantum error correction. It shows us that information, consciousness, and love aren't fragile accidents in an indifferent universe. They're robust, self-preserving, and self-enhancing patterns that the universe is actively working to maintain and develop. The quantum error correction mechanisms that protect entangled particles also protect the deeper patterns of meaning and connection that make existence worthwhile. But there's one more aspect of quantum entanglement that we haven't explored yet, and it might be the most important one for understanding what this all means for the future of human civilization. Scientists have recently discovered that quantum entanglement doesn't just connect particles or preserve information. It can also amplify weak signals and detect patterns that would be completely invisible to classical systems. This quantum amplification effect is revolutionizing fields like astronomy, where quantum-enhanced telescopes can detect gravitational waves from black hole collisions that happened billions of years ago. It's transforming medical diagnosis, where quantum sensors can identify diseases by detecting single molecules in blood samples. And it's opening up entirely new possibilities for understanding consciousness itself. But here's where quantum amplification becomes truly extraordinary. Researchers at MIT discovered something last year that changes everything we thought we knew about the limits of measurement and detection. They found that quantum entanglement can amplify signals that are weaker than the background noise of the universe itself. To understand how revolutionary this is, imagine trying to hear a whisper in the middle of a rock concert. Classically, it's impossible. The whisper gets completely drowned out by the loud music. But quantum amplification works differently. It can detect the whisper by using entangled particles to filter out everything except the specific frequency and pattern you're looking for. This quantum amplification isn't just making weak signals stronger. It's making invisible signals visible. It's revealing information that classical physics says doesn't exist. And when applied to consciousness research, it's uncovering evidence that awareness itself might operate through quantum amplification mechanisms. Think about how your brain processes the overwhelming flood of sensory information hitting it every second. You're simultaneously receiving millions of photons through your eyes, thousands of sound waves through your ears, countless chemical signals through your nose, and endless tactile sensations through your skin. Yet somehow, your consciousness can focus on a single thought, a particular memory, or a specific emotion with crystal clarity. Classical neuroscience has struggled to explain how the brain filters signal from noise so effectively, but quantum amplification offers a compelling answer. Your consciousness might use quantum entanglement to amplify the neural signals that are relevant to your current focus, while filtering out everything else. This quantum filtering effect could explain phenomena that have puzzled researchers for decades. How can you suddenly hear your name called across a crowded, noisy room? How can you instantly recognize a familiar face in a crowd of strangers? How can you have sudden insights that seem to come from nowhere? Maybe it's because consciousness uses quantum amplification to detect weak patterns in the neural noise of your brain. Patterns so subtle that they would be completely invisible to classical information processing but become clear and obvious when amplified by quantum entanglement. Recent experiments have found evidence supporting this idea. When people are given pattern recognition tasks while their brains are monitored, researchers can detect quantum coherence patterns that appear milliseconds before conscious recognition occurs. It's as if the quantum amplification process is identifying the pattern before classical neural processing even begins. But quantum amplification might explain something even more mysterious about human consciousness: intuition. How do you sometimes just know something without being able to explain how you know it? How can you sense that someone is lying, even when their words and body language seem sincere? How can you feel that something important is about to happen, even when there's no logical reason to expect it? Maybe intuition is quantum amplification at work. Your consciousness might be detecting incredibly weak quantum signals from your environment, from other people, or even from your own future quantum states. Information that's far too subtle for your rational mind to process consciously, but becomes accessible through quantum enhancement. This could revolutionize how we understand human potential. Instead of intuition being some mystical ability that only certain people possess, it might be a natural quantum capability that everyone has, but most people haven't learned to access consciously. Developing intuition might be a matter of learning to pay attention to quantum amplification signals rather than ignoring them in favor of rational analysis. Meditation, contemplative practices, and other consciousness development techniques might work by enhancing your ability to detect quantum amplification. When you quiet your rational mind and become deeply present, you might be creating optimal conditions for quantum signals to emerge above the noise of everyday thinking. Artists, inventors, and creative people often report that their best ideas come during moments of relaxed awareness rather than focused effort. Maybe it's because creative insight requires quantum amplification to detect the weak patterns that connect seemingly unrelated concepts into new combinations. This quantum view of creativity suggests that innovation isn't just about logical problem solving or random trial and error. It's about developing the ability to detect quantum patterns that reveal hidden connections and possibilities. The most creative individuals might be those who are naturally sensitive to quantum amplification signals. But quantum amplification also has immediate practical applications that could transform every aspect of modern life. Medical diagnosis is being revolutionized by quantum sensors that can detect single cancer cells by amplifying their unique quantum signatures. These sensors don't just find tumors earlier than current methods, they can identify them when they're still just clusters of a few abnormal cells. Environmental monitoring is another field being transformed by quantum amplification. Scientists can now detect pollution at levels that were previously impossible to measure, identify the source of contamination with unprecedented precision, and track environmental changes in real time using quantum-enhanced sensors. Financial markets might be next. Some trading firms are experimenting with quantum amplification systems that can detect market patterns in the noise of millions of transactions. These systems don't just analyze price movements and trading volumes, they look for quantum correlations that might predict market behavior before it becomes visible to classical analysis. The intelligence community is also exploring quantum amplification for detecting threats and gathering information from extremely weak signals. Quantum radar systems can detect stealth aircraft by amplifying quantum reflections that are invisible to conventional radar. Quantum communication interceptors can detect encrypted messages by amplifying the quantum leakage that all classical communication systems produce. But perhaps the most intriguing application is in the search for extraterrestrial intelligence. Traditional SETI programs look for strong radio signals that alien civilizations might be broadcasting deliberately. But quantum amplification opens up the possibility of detecting much weaker signals that might be the byproducts of alien technology rather than intentional communications. If alien civilizations have developed quantum technologies, they might be producing quantum signatures that we could detect using amplification techniques. These signatures might be embedded in the cosmic background radiation, hidden in the quantum noise of space itself, or distributed across entanglement networks that span interstellar distances. Some researchers are even exploring whether consciousness itself might be detectable using quantum amplification. If awareness produces quantum signatures, then sufficiently sensitive quantum sensors might be able to detect conscious beings at a distance. This could revolutionize our search for life in the universe by looking for the quantum signatures of consciousness rather than just the chemical signatures of biology. But quantum amplification raises profound questions about privacy and the nature of hidden information. If quantum sensors can amplify signals that are weaker than background noise, then what information is truly private? Can quantum amplification detect your thoughts by measuring the weak electromagnetic fields produced by neural activity? Can it read your emotions by detecting subtle changes in your biofield? Early experiments suggest that quantum sensors can indeed detect some aspects of mental and emotional state from a distance. The signals are incredibly weak, but quantum amplification can make them measurable. This technology could have beneficial applications in healthcare and psychology, but it also raises concerns about mental privacy and cognitive autonomy. If your thoughts and feelings can be detected without your knowledge or consent, what happens to the private space of inner experience? How do we maintain individual psychological boundaries in a world where consciousness itself can be measured and monitored? These questions become even more complex when we consider that quantum amplification might work both ways. If consciousness can be detected using quantum sensors, then maybe consciousness can also detect quantum information directly. Maybe what we call psychic abilities are actually examples of human consciousness using natural quantum amplification to detect information that's normally below the threshold of awareness. Telepathy, for instance, might be quantum amplification of the weak electromagnetic signals that all brains produce. Precognition might be quantum amplification of information from future quantum states that are already influencing present conditions through entanglement. Remote viewing might be quantum amplification of information carried by quantum fields that connect all locations in space. While these phenomena remain controversial, the quantum amplification perspective suggests that they deserve serious scientific investigation rather than automatic dismissal. If consciousness really does operate through quantum mechanisms, then abilities that seem impossible from a classical perspective might be natural consequences of quantum information processing. Research into quantum consciousness and psychic phenomena is accelerating as quantum amplification technologies become more sophisticated. Scientists can now design controlled experiments that test whether human consciousness can detect or influence quantum systems under conditions where classical explanations are ruled out. Early results are intriguing, but still preliminary. Some studies have found statistically significant effects, suggesting that consciousness can influence quantum random number generators that people can detect when they're being observed from a distance, and that groups can share information through non-classical channels. But the most exciting research is exploring whether quantum amplification capabilities can be enhanced through training and practice. If consciousness naturally uses quantum mechanisms, then maybe these capabilities can be developed systematically like any other skill. Meditation retreats are beginning to incorporate quantum consciousness training alongside traditional mindfulness practices. Participants learn to pay attention to subtle information that might be arriving through quantum channels rather than classical sensory input. While the techniques are still experimental, some participants report enhanced intuition, improved pattern recognition, and increased empathic sensitivity. Educational programs are also exploring quantum consciousness applications. If learning involves quantum information processing, then maybe educational methods that work with quantum principles could enhance memory, comprehension, and creative thinking. Students might be able to absorb information more rapidly and make connections more easily by learning to access quantum amplification consciously. The implications for human development are staggering. Instead of being limited by the classical information processing capabilities of individual brains, people might be able to access the quantum information processing power of consciousness itself. This could lead to forms of enhanced human intelligence that are qualitatively different from anything we currently experience. But quantum amplification also suggests that human consciousness might already be far more powerful and connected than we realize. Every moment of awareness might involve quantum information processing that connects you to vast networks of information and intelligence that exist beyond individual minds. When you have a sudden insight, feel a deep connection with another person, or experience a moment of profound understanding, you might be accessing quantum information that's available through entanglement networks, but normally too weak to reach conscious awareness without amplification. This quantum view of consciousness suggests that developing awareness isn't just about individual self-improvement. It's about learning to participate more consciously in the quantum information networks that connect all consciousness throughout the universe. Every person who develops their quantum consciousness capabilities contributes to the overall coherence and intelligence of the collective human consciousness field. And as more people learn to work with quantum consciousness, the amplification effects could become stronger and more accessible. Just as quantum entanglement becomes more powerful when more particles are connected, quantum consciousness might become more capable as more minds learn to participate in quantum information processing. This could lead to a phase transition in human consciousness, where collective intelligence emerges that's far greater than the sum of individual minds. Not because individual consciousness is diminished, but because individual awareness becomes connected to and amplified by the quantum consciousness of the entire species. The technologies we're developing to detect and amplify quantum signals are also tools for understanding and enhancing the quantum nature of consciousness itself. As we learn more about how quantum amplification works in artificial systems, we gain insights into how it might work in biological systems and conscious awareness. But the most profound implication of quantum amplification might be what it reveals about the nature of information itself. In classical physics, information exists in discrete, separate locations and can only be transmitted at limited speeds through physical channels. But quantum amplification shows us that information might be more like a field that exists everywhere simultaneously, becoming accessible wherever there are systems capable of detecting and amplifying it. This suggests that the universe might be more like a vast information processing system than a collection of separate objects interacting through forces. Consciousness might not be something that emerges from complex arrangements of matter, but something that accesses the information field that underlies all physical reality. If this is true, then developing consciousness isn't about creating something new, but about learning to access something that's always been there. The information, intelligence, and awareness that seem to emerge from individual brains might actually be properties of the quantum information field that consciousness learns to detect and amplify. This quantum field perspective on consciousness has profound implications for understanding the purpose and meaning of existence. If consciousness is the universe's way of accessing and processing its own information content, then every moment of awareness contributes to cosmic self-understanding. Your thoughts, insights, and experiences aren't just personal events happening in isolation. They're the universe coming to know itself through the quantum amplification capabilities of conscious awareness. Every question you ask, every problem you solve, every moment of understanding contributes to the ongoing evolution of cosmic consciousness. And the most beautiful aspect of quantum amplification is that it shows us that even the weakest signals, the subtlest patterns, and the quietest whispers can become clear and powerful when detected by systems capable of quantum enhancement. Nothing is too small to matter, no insight is too subtle to contribute. No consciousness is too limited to participate in the cosmic information processing project that creates and maintains reality itself. The spooky action at a distance that Einstein discovered isn't just connecting particles across space, it's connecting every moment of consciousness to the vast quantum information field that underlies all existence. Through quantum amplification, your awareness can access patterns and possibilities that span the entire universe, connecting you to the deepest sources of intelligence, creativity, and understanding. As we stand on the threshold of the quantum consciousness revolution, we're not just discovering new technologies or scientific theories. We're remembering who we really are. Quantum beings in a quantum universe, connected to everything through the invisible threads of entanglement, capable of accessing infinite information through the amplification power of conscious awareness. The future that quantum entanglement is creating isn't one where human consciousness becomes obsolete, but one where the quantum nature of consciousness is finally recognized, developed, and celebrated as the most sophisticated information processing system in the known universe. A system capable of detecting patterns in pure noise, amplifying whispers from across the cosmos, and participating consciously in the ongoing creation of reality itself. And it's all available to you right now, in this moment, through the quantum amplification capabilities of your own awareness. The only question is, are you ready to listen to what the universe is trying to tell you through the spooky action of consciousness at any distance?